All right, why don't we go ahead and get started? Welcome to today's webcast on accelerating and simplifying blockchain application development. Let me briefly introduce the speakers. I'm Mark Milovich. I'm part of the Oracle development organization responsible for our blockchain products, and particularly blockchain platform. With me today, we have Todd Little, our chief architect, and Bala Vilanki, who is director of blockchain product management. We are going to show you today a few really interesting things about the innovation in Oracle blockchain platform, and specifically the new capability, new component called Blockchain App Builder that is aimed at developers who are working on creating blockchain applications, creating smart contracts or chain codes as we call them, and we'll show you some demos of this new and exciting capability. But let me get started first by talking a little bit about the blockchain landscape overall. There is this quote from Frank Song, Oracle's Group Vice President of Blockchain Product Development, about his projection that between 50 and 60% of companies will use blockchain in the next few years. That's a pretty aggressive projection, I would say. And we're doing a lot at Oracle to ensure that that's possible. We are trying to remove a lot of barriers that companies have in adopting blockchain technology, making it easy to deploy, making the whole infrastructure experience simpler and quicker, and at the same time, now beginning to focus on simplifying the developer experience as well. So all of the barriers that people can envision from a complexity perspective, as well as the skills required, we can try to address by providing better capabilities in our software, better tools for developers that help to improve their productivity and simplify the development. In fact, enabling low-code development approaches to blockchain applications. Now, just to give you a little bit broader perspective of where Oracle is in the blockchain space, there is a lot of different blockchain models sort of out there, right? So you're all familiar with public blockchains such as Bitcoin and Ethereum, which are what we call permissionless or anonymous blockchains, where anybody can download the software and join and participate in those transactions without revealing their identity. Those types of blockchains are not generally used in enterprises because enterprises need to know who they're doing business with. And so they prefer to use permissioned blockchains where there are known identities of the participants, of the legal entities, if you will, the companies and other organizations that might be involved. So that they have agreements between them and they have perhaps even past dealings with them, and they can pursue ultimately legal recourse if something happens inappropriate, etc. There is other means that they can then enforce, their rights and such. So permission blockchains are key to success of enterprise blockchain, and they also happen to be much more effective from a performance and scalability perspective, by allowing much higher transaction rates into thousands of transactions per second, and provide a lot of additional security capabilities and business capabilities necessary for the adoption of blockchain in an enterprise space. They tend to range from private blockchains, which may be legal entities within a single organization, maybe subsidiaries use to conduct business, to consortium blockchains where separate companies get involved, to this new emerging models that we refer to as public permissioned blockchain, where you have the writers and validators that are permissioned and known entities, but public access, and public in quotes, is permitted for read operations, read access, without having, to require kind of membership in the blockchain. So this is essentially where the authentication of the users happens outside of the blockchain itself, and then on behalf of the authenticated user, somebody can provide the access to read the data. Now, Oracle's vision around enterprise blockchain space is to facilitate this concept of business organizational networks, whether it's creating rapidly new ones or significantly optimizing existing networks by leveraging the core capabilities of trusted transactions and single source of truth that the blockchain enables in a distributed ledger without requiring any kind of intermediaries. And to do that, Oracle is focusing on making the adoption of blockchain easy and quick for enterprises by providing a few different offerings. First is our Oracle blockchain platform. That's an offering that's available both as a cloud service and on premises. And it's focused on customers and developers who are looking to build their own solutions on a horizontal platform that provides all of the capabilities and tooling necessary, but can be used in a variety of industries and verticals and so on. And we have a number of customers with custom applications, as well as ISV partners, system integration partners who are building on this platform. In addition, we have a SaaS application called Intelligent Track and Trace that's specifically built as a solution for business users in supply chain management that allows them to quickly register together with their partners and conduct business on this platform to do track and trace, integrating data from multiple sources, visualizing it, tracking it, etc. And this application is built on top of our platform and is available as a SaaS application. Now, when we said that we try to make the blockchain easy and quick for enterprises, we really mean it at the level, not just from a deployment perspective, which we do, obviously. We provide a very pre-assembled, easy, quick to provision environment, but all the way through the entire life cycle of a blockchain project. So that means easy to integrate with a variety of systems of record. We provide very extensive REST APIs and the ability to subscribe to blockchain events. We work with client SDKs for more complex integration scenarios, as well as you can leverage a number of enterprise adapters available in Oracle Source with Oracle Integration Cloud, etc., to work with a variety of applications, Oracle and third-party applications that might need to integrate to drive blockchain transactions or consume events, regardless of whether those applications are deployed in the cloud or on premises or third-party cloud. We also make it easy to secure in terms of initial membership in the blockchain. As I mentioned, it's a permission blockchain, so there is a process of joining the blockchain that requires identity management, ability to secure private data within the blockchain so that not everybody can access and see all of the data that people are sharing, and on-chain access control mechanisms recently introduced with fine-grained access control lists to make it even easier for developers to be able to enforce granular access control policies. We make it easy to operate without requiring a PhD in blockchain by providing a best-in-class set of capabilities in terms of a web console, REST APIs, and tooling for all of the configuration and management and operations that you need. Also, we provide a built-in, out-of-the-box, highly available deployment options and dynamic scaling ready for enterprise production, and unique integration with analytics capabilities, so you can actually see what's happening from your, in a blockchain network, and do a lot of analytics and business intelligence kind of on the data that's flowing through the network. And finally, we make it easy to expand from a few nodes that typically you would start with to larger scale deployment across an ecosystem, regardless of the preferences of those individual ecosystem members and participants, whether they want to deploy something on premises, they want to deploy it in Oracle Cloud, they want to deploy it in third-party cloud. And we support very flexible topologies that enable everybody to deploy exactly the same way as they feel comfortable, and even join with non-Oracle blockchain nodes of Hyperledger Fabric provided by other vendors. Now, all of those capabilities are focused on making easier kind of the infrastructure areas of the blockchain. So if you think about the operations and the infrastructure requirements, that's what we've spent a couple of years working on since our release in July of 2018, so a little bit over 2 years now. More recently, we focused on the application aspects where we still feel that many companies are finding it difficult to find the right skills to develop applications. And so we're focusing on it from two perspectives. The first one is by continuing to expand the portfolio of industry solutions available from both Oracle and our partners. We have a significant number of ISV solutions available on the platform across financial services industry, manufacturing, retail, healthcare, education, distribution, and public sector. And now we're also focusing on speeding up the custom application build with this new component that we call Blockchain Application Builder, or App Builder for Oracle Blockchain Platform. And it's focusing on aiding developers, increasing their productivity through testing, deployment, etc. But it's also focused on providing low-code development capabilities to folks that may not be hardcore developers and want to be able to very quickly and easily use generated code, pre-generated code that this tool now makes possible as well. And we'll show you exactly how that's done. Now, just before we turn to the tool itself, a couple of words on Oracle Blockchain Platform. As I mentioned earlier, it's an enterprise platform. It's built on open source Hyperledger Fabric project from Linux Foundation. We work very closely with the Hyperledger community, participate in a lot of its activities. And what we've done is we've taken the open source versions and we've integrated them with a variety of Oracle capabilities in our cloud environment to create a pre-assembled offerings that you can go into an Oracle cloud and provision, and literally a couple clicks, 5 to 10 minutes later, it comes back and says it's all ready. And the entire system, the entire set of nodes necessary to operate Hyperledger Fabric are there and available for you. The peer nodes, ordering nodes, the Fabric CA for membership services, etc., as well as our API gateway and management console. All of those are deployed, and depending on whether you choose a standard edition or enterprise edition, it can be deployed in a highly available configuration across multiple availability domains for you. It's a very open environment. We follow all of the APIs and protocols in Hyperledger Fabric, and we can interoperate with non-Oracle nodes, as I mentioned, as well as our enterprise edition, which is container-based deployment on premises for those customers that prefer to do that as opposed to using Oracle Cloud or want to deploy it into third-party clouds even. It's an environment that provides a great deal of plug-and-play capabilities through the REST APIs that I mentioned that you can easily invoke from a variety of applications, whether it's on premises or in clouds, client SDKs, as well as integration adapters for things like Oracle and third-party ERP systems, CRM systems, supply chain management systems, and many, many others. We've infused a lot of enterprise-grade features. I talked about high availability. We do a lot of work around making data management easier, parallelize a lot of activities to improve the performance, dynamic scalability, and so on, so that this is really ready for prime time in terms of production deployments. And we focused a lot on automating the DevOps and providing REST APIs, very extensive set of REST APIs for all manner of configuration, scaling, management, monitoring, operational aspects, so that you can integrate this into any kind of a DevOps environment. And you can also use, of course, our web UI console that we provide. But if you prefer to do this from other tools, that's entirely possible as well. Now, we have some unique value propositions in this platform that I wanted to highlight. The first one is that we provide SQL-based rich data queries. The data management in the blockchain itself is based on key value stores, and we use Berkeley DB to provide a very highly performant, highly scalable key value store. But we put a SQL-like layer on top of it, which enables us to then move very rapidly for developers to provide SQL-based access into the queries. We provide analytics integrations through data visualization, reporting capabilities by streaming the transaction data into Oracle database relational schema and then integrating with Oracle and third-party analytics. We simplify onboarding for the kind of client member organizations that will not run the node, the kind of low-tech organizations. You might think, for example, in the food kind of agriculture ecosystem, you have farmers, right? They're not going to be running nodes. They just have a mobile app to be able to scan something. And they can be registered as clients, issue certificates, and participate as members without requiring any infrastructure deployment. We focus on confidentiality and privacy and recently created fine-grained access control list mechanisms that enables chaincode developers to enforce access control on specific data objects, fields, functions, etc. And bidirectional integration that is enabled by our API gateway through the REST APIs and through ability to subscribe to events and receive callbacks on those events is something that's very important for ERP integration and any kind of back office systems that might need to consume the data or drive transactions. And finally, very flexible deployment topologies that I mentioned earlier that interoperate with other non-Oracle Fabric nodes so that you're not locking yourself in, and ability to run geo-redundant clusters as well, deployed across many different data centers and regions and continents. Now, I mentioned that we have also made available an enterprise edition of Oracle Blockchain, and this is for customers that have requirements for operating in countries where there's data sovereignty, data residency requirements, or industry preferences, or just, customer itself decides they want to run it on premises. So all of the capabilities I talked about, you can essentially download an appliance, software appliance, and deploy it into a virtualization environment such as VMware or VirtualBox and so on. And it provides similar capabilities through what we call our platform manager, blockchain platform manager, that manages and orchestrates the entire environment for you. Feature parity with all of the cloud services as well, so that you could run applications on either environment for portability. And then, if you prefer, you could do development and testing in the cloud, deploy production environment on premises, or have hybrid environments where you're operating a network that includes both on-premises and cloud-based nodes or even third-party nodes. Now, often what we see is a more complete sort of architecture, solution architecture that customers deploy, including not just a blockchain platform, but also integration services and capabilities, adapters for a variety of back office systems, and then integrations through the database schema with analytics as well, and security identity management. Typically, then you could do very easy drag and drop kind of integration and orchestrations. You can create visualization dashboards and reports very easily, but you still have to write code for smart contracts, or chain code as we call it, and then also for the application front ends if you have mobile applications or web front ends and so on. So what we try to focus on then is making it easier for customers to actually write the chain code, and in some cases not have to write it at all, right? That's sort of the last mile, if you will. So we do that by creating capabilities in our blockchain application builder that allow you to use a specification file that defines the assets you want to manage on the blockchain. You could define them with certain attributes for, could be documents or product information or anything that really matters that you want to track on the blockchain. And that specification file then is used by the app builder to generate and scaffold the project and generate the CRUD methods for the chain code, right? So basic create, read, update, delete type methods and implementations that are generated automatically for you. You can then go and add custom implementation methods if you need to. If you need to make more complex business logic available in your chain code, you could do that. You can then go ahead and deploy the smart contract locally. We create a local Hyperledger Fabric environment with peer node, order nodes, etc., so that you can do local testing. That means that it's much faster to iterate. And as important, you can use line-by-line debugging capabilities in a local testing environment, which are difficult to use when you deploy in a contained environment in the cloud. Once you've gone through the test and debug cycle, you can then package the chain code and deploy it into an Oracle blockchain platform, whether it's running in the cloud or on premises. And this is an automated process as well. So let me turn it over to Todd Little, who will take us through some details of the application builder. Todd. Go ahead.
Sorry, I thought I unmuted myself. I had not. Thanks, Mark. So the app builder, as Mark says, provides two different interfaces. We have a nice GUI interface that's based on an extension for Visual Studio Code. And then we also provide a CLI that can perform all the same functions. And this is provided so we can do scripting and do CI/CD integration. So from a spec file, we can scaffold a new blockchain project, which is essentially a smart contract or chain code, as we call it. We can deploy to both Hyperledger Fabric network locally or to the Oracle blockchain platform. We have the ability to be able to deploy and test locally. We can do line-by-line debugging, and all this stuff I'll be able to show you here in a minute. And as well as to be able to deploy both in a local or remote OVP network. So either the Oracle Blockchain Cloud Service or the Oracle Blockchain Platform Enterprise Edition. And finally, what I'll show is a little bit about some of our enhancements around rich queries and how we can use SQL statements to be able to dramatically improve the performance of your application. So the major portion of, or the starting point, maybe the best way to describe it, for a blockchain application using the blockchain app builder is what we call a specification file. This defines the assets that are to be used in your application. It creates essentially a model controller model or design where the model defines all the properties or assets of the assets, and the controller defines all the behaviors that are associated with the assets. In the specification file, you can define multiple assets. You can have validations that occur for each of the properties on those assets. And I'll describe and show a lot of this in the demo here in a minute. We also automatically can generate CRUD operations, so for create, read, update, and delete, and as well to be able to integrate your own custom business logic. We provide transparent persistence, meaning that you don't have to do things like get state and put state. You simply use classes, and then the classes then provide the ability to be able to persist the instances of those classes to the key value store. And as well, then we provide the ability to be able to regenerate when you make specification changes, because you may learn about things about the problem that you're trying to solve after you've already created your initial specification and scaffolded your project. So we have a couple of examples that get included, which are the FabCar and Marvels example. And I'll be basing this demo on FabCar. So as I say, we start with a model view controller design pattern, and we use decorators then in the code then to be able to hide much of the complexity associated with the validations that must take place. It's declarative. So instead of writing code for much of the stuff, you define what you want to happen. So this really is sort of a low-code development environment, although it doesn't limit you in that respect. Again, the model defines the asset's properties and any attributes associated with each of those properties, and then the decorators are used then to be able to define what the constraints are for those properties. Then the controller then defines all the behavior associated with the asset, and that is extensible by the developer, so they can define their own custom methods. So the flow is you create a specification file. This defines the assets and their behavior. You then scaffold a project. So this creates then a blockchain project using the normal development environment for either TypeScript or Go, and it generates then the model and controller files. You can then implement the custom methods that you've defined that are unique to your particular business application. So these are things that are above, beyond CRUD, but CRUD methods also get generated automatically. Then you can run this chain code locally. So you can do many testing. And as you do the testing, as you make changes to the code, those tests, the code is updated automatically inside the chain code environment. So you don't have to go through the whole life cycle of deploy, instantiate, and all that. But you also then can do that against an Oracle blockchain platform instance. So the specification file is either a JSON or YAML file. You can see one here. It shows, we're defining a marble here. The marble has a property called marble ID. It's the ID for the particular asset. There's some validations that take place, such as the color can only be red, blue, or green. So that's done by using a regex, or regular expression. The auto-generated properties are down here under methods. So this is the create, get by ID, and update. So we don't provide the delete mechanism. And as well, then other assets and the methods for those. So this defines basically what your application is going to be able to do and what the data is that it provides. Let's go to the next slide. So I'm going to do a little demo here. So I'm going to show how using the CLI to be able to create and scaffold a project from a specification file. We'll run that chain code locally, and then we'll also then deploy it and run it on an Oracle blockchain platform instance. And then I'll show using the Visual Studio Code extension. So again, we'll scaffold a project. We'll add some custom method implementations. We'll do little bit of line-by-line debugging, and then finally explain a little bit more about the SQL-based rich queries that Mark had talked about. The key information needed by the blockchain app builder is in a specification file. This file, in either YAML or JSON format, defines the assets the generated chain code will use, as well as the behaviors or functions associated with those assets. The specification file can define multiple assets, each with multiple typed properties. Associated with these properties are any validations that must take place, such as ensuring a property adheres to the syntax of a URL or email address. If we look at this specification file for a simple smart contract that will manage cars, dealers, and consumers as assets, the car asset has the following properties: the VIN, the make, the model, the year, the color, owner ID, price, and the last sold date. For each property, a set of attributes can be defined, such as the name of the property and the type of the property. If we look at the VIN property, we can see it has a name of VIN, is of type string, is mandatory or required, an ID that will be used as the primary key for the car entry, and finally a validation attribute that is in this case indicates that the string must have at least 17 characters and no more than 17 characters. In other words, exactly 17 characters. Another example of validation is on the make property. In this case, the property is a string, but that string must match a regular expression. The regular expression given here checks to make sure the make is one of those enumerated in the comment. Basically, this ensures the make is one of an enum. Min and max validators can also be used on number properties, such as seen in the year property. Blockchain App Builder can handle validation of a number of attributes of a property. For example, here, the email property on the dealer and owner assets, we define it as a string, but with a validation that it must adhere to a syntactically correct email address. Validators help by making it explicit what makes a property valid using declarations instead of having to implement these checks in your chain code yourself. This speeds up development and makes it clear to others what is expected for the properties. Following the properties of an asset is a section defining the methods that can be automatically generated by the Blockchain App Builder for the asset. By default, there are 4 CRUD methods, create, read, update, and delete, that can be generated. In addition, there are 2 other methods that can be generated, one that provides a history of the asset, and the other allows retrieving assets by a range of key values. Finally, after all the assets are defined, there is one last section that defines custom methods for the smart contract. These will also be exposed as invocable chain code functions. The one listed is another automatically generated method that executes an arbitrary rich query against the state database. Thus, the execute query chain code function is provided that takes a query as a string and returns the results of the query. While this may not sound very interesting, the issue is that the state database is an embedded database sitting inside the peer. The only way to access the state database is by querying or invoking a chain code function. So using this function, one can test query after query using the same chain code. In other words, without having to redeploy or your chain code for every test. Later, we'll add some application-specific custom methods where the implementation has to be provided by the developer. Now that we have a complete specification, we can use the ochain init command to scaffold a chain code project and generate the model and controller files for the chain code. You can see the list of files generated. After the project is scaffolded, it is built, meaning for TypeScript projects, all the necessary node modules are installed into the project. This can take a few minutes as there are many node modules to install. Meanwhile, let's look at the generated code. Blockchain App Builder relies on a model controller design where the model defines a concrete class for each asset along with the runtime validations that should take place. As you can see in this model file, the validations are declared using annotations. This makes it obvious to any developer what validations will take place without having to code them. So looking at the year property of a car, we can see that it is a number and must be between 1910 and 2020. Also notice at the top of the class definition is a static read-only property named asset type that has a type of fabcar.car. This tells Blockchain App Builder that when it retrieves this asset from the state database that it is a car. Otherwise, the developer would have to cast the asset as a car, which would be a pain. If we now look at the controller file, we'll see the CRUD functions we asked to be generated, as well as any other custom methods. If we look at the create car method, we can see that the implementation is trivial. Just save the car by calling the superclass's save method. Blockchain App Builder provides transparent persistence capabilities by automatically handling the marshalling and unmarshalling of the asset, as well as managing the instance in the state database. This relieves the developer of having to use the getState and putState functions, although they are certainly allowed to do so. Blockchain App Builder generates standard Fabric chain code that can be modified by the user and provides an extensible library that includes access to the Fabric shim. Thus, the chain code can bypass Blockchain App Builder's library and directly invoke the shim functions. Okay, now that the project has been scaffolded and built, let's run the chain code locally. To start the chain code, we'll use the ochain run command. This will start up a local Fabric instance containing one peer, one ordering service node, and the Fabric CA. Blockchain App Builder will pull the necessary Docker images, start the containers, and then start the chain code in development mode. This allows the chain code to be started and managed externally instead of by the peer. Now that the local fabric instance has started and our chain code has been deployed and running, we're ready to test the chain code. Let's open another terminal window and use the ochain invoke command to invoke our freshly created chain code. The invoke command takes one mandatory argument, which is the name of the chain code function to invoke. It also takes optional arguments that are passed to the chain code function. So in this case, we can see that we're invoking the createCar method, one of the generated CRUD methods. Passed to that function is a JSON object representing the car to be created. It has the VIN, the make as a Ford, the model as an Escape, the year as 2015, and the color is black. If we try to execute that invoke again, we see that we get an error because there's already a car with the VIN in the system. So at this point, we've created a spec file, scaffolded a chain code project from it, and then run and tested the chain code locally. Let's now see what it takes to run this chain code on the Oracle blockchain platform. As we've been running our chain code locally against a minimal fabric instance that doesn't include any identity management, we've been able to avoid any issues associated with authentication and authorization. However, when we want to run against the Oracle blockchain platform cloud service, we need to deal with authentication and authorization. I'll take you through the steps of authenticating and authorizing against an Oracle blockchain platform instance. The first thing needed is a connection profile. This profile defines the network endpoints and crypto material needed to connect to the blockchain network. Navigate to the Service Console for the instance. From there, select the Developer Tools tab. From there, we'll select the Application Development option on the left side. At the bottom of that page, you'll find the option to download the development package. I'll download that zip file and unzip it into a folder named OBP in the project directory. Next, we need to add credentials to be used in interacting with the blockchain service. Select the Network tab in the Service Console. From there, I'll select the Export Admin Credentials from the hamburger menu to the right of the instance name and download the zip file. At this point, we need to unzip the admin credentials and add them to the connection profile. This basically entails copying the public certificate and private key for the admin credentials to the appropriate place with the appropriate names. After this is done, the OBP directory looks like this. Now that we have the connection profile and credentials to use the Oracle Blockchain Platform instance, we're ready to deploy our smart contract to the OBP instance. First, we need to log into the OBP instance using the ochain login command. This command gets an enrollment certificate from the Oracle Blockchain Platform instance, and it will be used in subsequent ochain commands. Now we've logged into the Oracle Blockchain Platform instance, we're ready to deploy our chain code. This has to follow the standard Fabric chain code lifecycle, so that means first installing it on some of the peers and then instantiating it, i.e. starting it up, and then upgrading it every time we make changes. When we were testing locally, this was all done for us behind the scenes. With the Oracle Blockchain Platform, we need to explicitly deploy or upgrade the chain code. Fortunately, Blockchain App Builder simplifies this for us. Using the ochain deploy command, we can deploy or upgrade our chain code in the Oracle Blockchain Platform instance. So unlike in the local environment where we use the ochain run command to start a Fabric instance, the OBP instance is already running, but as it is remote, we need to deploy the chain code using the normal Fabric chain code lifecycle. The deploy command can take a few minutes as the chain code is zipped up and into a deployment package and then installed and instantiated on the peers in the Oracle Blockchain Platform instance. The instantiation step can take a few minutes. While that's finishing, let's look at the Oracle Blockchain Platform console and see that the chain code has been installed there and maybe even instantiated by this point. We can see in the chain code tabs that the chain code has been installed and instantiated on the two peers in my instance. Now that the chain code is running in our Oracle Blockchain Platform instance, We can test it using virtually the same commands as before, the ochain invoke command. Let's create some cars. Remember that now that we're working against an OBP instance, so the cars we created locally won't be present. Let's recreate them with this script to invoke create car a number of times. Let's go back to the Oracle Blockchain Platform console and take a look at one of the transactions. First, we navigate to the Service console, and from there we select the Channels tab. This will show us the default channel. By selecting the default channel, we can see the recent transactions. If we click on a block, we can see the transactions in this block. As we're submitting transactions at a relatively slow rate, each block only contains a single transaction. Clicking on the transaction shows us the details for that transaction. We can see that the create car function was invoked and a car created. Now that we've deployed and tested our chain code using the Oracle Blockchain App Builder CLI or command line interface, let's take a look at the Visual Studio Code extension that is included as part of the Blockchain App Builder. If we go into Visual Studio Code, we can see that I've already installed the extension. At this point, let's repeat the steps we did before, but this time from within Visual Studio Code. On the left-hand side, we can see the chain codes, specifications, and environment section. The chain code section represents the chain code projects that the Blockchain App Builder knows about. The specification section shows the specification files that have been created. And finally, the environment section shows the runtime environment definitions we can use to deploy and test our chain code against. Let's recreate our chain code project. We'll use the same sample specification file that was used in the CLI example. So we click on the plus sign next to the chain code section and create a new chain code based upon the provided sample. This opens up a pane on the right side that will let us fill in the name of the chain code. We use fabcar2 as fabcar has already been used. The language we'll leave as TypeScript and select the fabcar TypeScript sample specification file. And finally, the location for the project directory. We can see in the output window the files being created and the project being built. Once this is complete, we're ready to deploy and test the chain code. In the right pane, we select Deploy. We can accept the default parameters as we'll initially test the newly generated chain code in a local instance. As well, no initialization parameters are needed. As we can see in the Visual Studio Code output panel, the local Fabric instance has been created and the chain code deployed. We can now use the extension to test one of the chain code methods. Instead of using the chain invoke command, we'll construct the transaction in Visual Studio Code. By clicking on Execute tab of the chain code details, we'll see a panel that lets us select the environment, channel, function, and the parameters to use in the invoke. The default is the local environment, which is fine, and the channel is my channel, which also matches the local environment. Finally, we select the create car function and then select the three dots to the right of the parameter field. This takes us to a panel where we can fill in the object details necessary to pass a car to the create car function. So we enter in the VIN, the make, the model, the year, the color, and omit the owner ID and price and last sold date. We then click on Invoke, and VS Code performs the invoke against the local instance. Now, let's go back and add some custom methods to our chain code. Currently, our chain code only has CRUD methods, the get history by ID and get range by range methods, and finally the execute query method. Let's add a couple of additional methods to show how business logic is added to the chain code. One to add a car to the dealer's inventory, and another to sell a car either from a dealer to a consumer or from one consumer to another. At the end of the specification file, we'll add the add car and buy car custom methods as follows. Since we've changed the specification file, we'll need to regenerate the model and controller files. After saving our changes to the specification file, we can select the chain codes associated with the specification file to be synced. This will regenerate the model and controller files and merge any changes. Now that we've synchronized the model and controller files to the new specification file, we can add the necessary business logic for the add car and buy car methods. The controller file has a generated version of the add car and buy car methods, which are basically empty methods. Let's replace those empty implementations with real implementations that implement the following business logic. Add car adds a car to the dealer's inventory. The parameters are the VIN, the dealer ID, the price, and the last sold date. The car must already exist and can't already have an owner. We can see in the code that we can easily retrieve the car by using the getCarById function and the dealer using the getDealerById function. We check if the car has an owner, and if so, then report an error depending upon whether a dealer or consumer owns the car. If everything is okay, then the car's owner ID, price, and last sold date are updated, and then the car is appended to the inventory array for the dealer. Finally, we update the car in the state database. Buy car records the sale of a car by a dealer or consumer to a consumer. The basic business logic implemented in buy car is that the buyer and seller can't be the same. If the car has an owner, but it's not the dealer, then throw an error. If the owner is the current owner, then throw an error. Otherwise, we update the owner ID, price, and last sold date, add the car to the consumer's list of cars owned, and then determine whether the current owner is a dealer or a consumer by checking the asset type of the seller, as it could be a dealer or consumer. Then either removing it from the dealer's inventory or from the consumer's array of owned cars. To test our new methods, we need to first create some cars and at least one dealer and one consumer. I'll simply copy some ochain invoke commands to create a dealer with an ID of dealer 1, a consumer with an ID of consumer 1, and some cars. Now that the dealer, consumer, and some cars have been created, we can try the add car method. Let's start a debugging session so we can see how line-by-line debugging works. But let's first set a breakpoint in the add car method. Invoking add car finds us at the breakpoint we set. From here, we can step through the function to make sure it's doing as we expect. One last thing I want to show is how to use the execute query method to perform arbitrary rich queries. To do that, we'll use a copy of this chain code that has already been deployed to the Oracle blockchain platform and populated with some cars, dealers, and consumers. Using the ochain invoke command, let's execute this query that will get a count of the number of cars of each color each owner has. You can see the results showing which owners have how many cars of each color. As you can see, we're using a SQL select statement to perform the query. Because SQL allows computation to be pushed down into the database, we can perform various operations in a single select statement. If we look at this query, we can see that it will retrieve the number of cars each owner has and the average price of those cars. This query gets executed in a single round trip to the database. Calculating those averages without this capability would require retrieving all the cars in the database and performing the calculations in our chain code. Doing this would require at least n round trips to the peer to access the database where n is the number of cars in the database. The resulting read-write set would likely be enormous, and the function would take far longer than using a select statement as we've done before. Also, one final note about rich queries. Oracle Blockchain Platform carries a hash of the rich query in the read-write set and then re-executes the query at validation time to ensure that no dirty reads were encountered. This makes it safe to use rich queries in chain code decisions. Unlike the standard Fabric rich queries, which don't re-execute the queries at validation time, thus allowing for undetected dirty reads.
So what you've seen is a detailed walkthrough of the blockchain app builder. Now let me ask Bala Valanki to take us through the demo that he prepared, which is a unique application related to COVID-19 test results reporting.
Thanks, Mark. Today we are going to demonstrate how to build a simple application using a real use case. This use case is to capture COVID-19 test results from all the labs where the tests are performed for the patients. As we all know, HHS health officials want to ensure they have comprehensive and near real-time data from labs to inform decision making in their response to COVID-19. This simple application demo was developed and will make it easy for HHS to access the data provided by the labs. The new lab data provided to HHS by all the labs need to follow specific HHS specifications to publish the data. Here are the COVID-19 lab reporting implementation specifications provided by HHS to all the labs. All the labs will follow the same specifications when they submit the data to HHS. Now let's look into the steps involved in creating the simple application using Blockchain Application Builder, Blockchain Platform, and Postman REST Client. Using the Blockchain Application Builder, first step is to create a sample data spec YAML file based on HHS implementation specifications. Once the implementation spec is finalized, second step is to generate the project and smart contract to deploy on Oracle Blockchain Platform. We already configured Blockchain Platform with two organizations. One organization is HHS and the other organization is ABC Lab. For deploying the smart contract in step 3 and examining the ledger and chain code in step 4. Finally, in step 5 and 6, we are going to use the REST proxy API provided by the blockchain platform to perform a REST request from Postman. Now let's see how we can create a simple application using Blockchain App Builder. As mentioned in the previous demo from Todd, first step is to create a sample spec definition using YAML or JSON. Here are a few sample templates for car and marble provided by Blockchain App Builder. Before we start creating the YAML spec, let's take a look at COVID-19 lab reporting specs provided by the government. You can see the list of fields like test ordered, test result date, test reported date, test collection date, specimen date, device identifier, accession ID, patient age, patient date of birth, and all the patient info that is needed, and also the provider info, the test info, etc. in the spec. Now let's start creating stub definition in the app builder by giving valid name, extension, and folder to save. You can see the spec created based on the data definitions. Now let's start with opening the spec that we defined in our previous screen and start looking at the values or data that is being defined as per the guidelines. Here is the spec that you're looking at based on the guidelines. So once you can see the name as COVID-19 lab results, and if you go up and look down at the bottom, there are a few strings which we considered important that need to be defined here. So what I'm trying to do is comparing all these fields with the spec as we took from the government. So first one is, let's start with the test ordered, and we can see what validations we perform. Similarly, you can go and look at the string for test result and the others that are being defined here. The test result consists of specific values that are defined in the guidelines, and you can see that the numbers that we are validating. Now go down to the bottom of the screen and see the accession ID here, where we are validating about a minimum and max fields that we are considering. And also let's go and look at the patient age at the bottom. So you can see the patient age should be more than 0. And what we are defining here is any string that is positive there. So now go to the bottom and see the patient gender, which can be male, female, or unknown. So that's what we defined there for validation. And also going on looking at the ethnicity, you can see the numbers we are validating based on how they are defined in the guidelines. So at the end, what we are defining here is two custom methods. One is execute query and upload patient results. The update method helps the labs to upload the patient results, and the execute query methods help execute the query for HHS or labs to perform any query on the patient results. Now let's start generating the chain code in App Builder using the specifications defined in the previous step. Let's start specifying a name, programming language, and a program you want to generate the code, and select the specification that you need to create and the location where you want to deploy. Once you click on create, the chain code will be generated, and you can see that on the output console at the bottom of the screen. You can go and click on the chain code tab and look at the code that has been generated. So as the chain code has been created, let's go and look at all the things that we defined in the YAML file or the spec file and see whether they're created. So let's start with the model file that has been created for performing all the validations and the data definitions that we defined in the spec. So you can start. We can look at the test ordered, accession ID validations, and the patient age, gender validations that we defined, with all other values that we talked about in the guidelines. Let's look at the controller file and methods generated by the app builder. You can see all the methods defined as part of the CRUD functionality, like create, update, and save for the defined spec. Now let's update the custom methods, execute query, and upload patient results. First, let's go and look at the upload patient results method that I'm going to update with the code to insert the results into the ledger. The functionality of this custom method is to write patient results provided by the lab to the ledger. Upload patient results will also receive patient COVID result input from the labs and the other lab organizations to go and update the ledger. So once you go and update all these parameters, you're going to go and invoke one of the CRUD functionality called create COVID-19 results from the update custom method. Another method, execute query, is the custom method that will be created by the app builder to retrieve patient results from the ledger. Now, for the purpose of this demo, I created a blockchain network with a couple of sample organizations in the Oracle blockchain platform. And one organization is government organization, say HHS, and the other organization is ABC Lab. Two organizations in the network are connected via a channel. You can see that in the network diagram as shown on the screen. We are going to use that channel and chain code to query and publish the data to the ledger. To establish connection to an organization from the blockchain app builder, it requires an organization connection profile. To create a connection profile for an organization, connect to the blockchain network node, go to application development section of the developer tools section, and follow the steps mentioned under OBP. Once the connection profile is created, let's start creating the environment connection from blockchain app builder. After the connection is established, let's go and deploy the chain code to Oracle blockchain platform from which the connection was established. You can see the process log of installation and instantiation in the output tab of the app builder. Now let's go and see the blockchain platform admin console and check out if the chain code has been deployed. As we need to deploy the chain code on all the participants on the network, you can see that the chain code is not deployed in HHS government node. So let's go to the blockchain app builder and build a chain code package to deploy it manually on the HHS government node. After the package has been successfully built in the blockchain app builder, now let's take the package and start deploying the package on the HHS government node manually. Click on the deploy new chain code button on the HHS lab node and select advanced deployment option and pass on the values that are needed to deploy the chain code, like installation and instantiation. So the instantiation of the process would fail in this case because the chain code has been already instantiated in our previous step in the ABC Lab node. Oracle Blockchain Platform provides a powerful REST proxy embedded with SDK and load balancer to invoke the chain code. The REST proxy can be invoked via any REST client like Postman. The REST proxy is unique to every organization in the network. As you remember, we created two custom methods in the chain code called upload patient results and get COVID-19 results by ID. Let's try to invoke these methods from ABC Lab and HHS. To invoke the Postman transaction named upload patient result from ABC Lab node using REST client, we need the URI, name of the chain code, method name, and the lab results of the patient and the channel name. After the successful invocation, let's go to the ABC Lab admin console on which we performed the invocation to see the block content created for the transaction. You can also see the same block and transaction from HHS government node admin console. Now let's go to the government organization console and see if the transaction has been replicated. Now you can see the same transaction here as well. Finally, let's go and query the transaction from the government node REST proxy using the same patient info uploaded from patient lab REST proxy. Get all the parameters like the REST proxy URL, name of the chain code, name of the method called government COVID-19 results by ID, and patient accession ID, and the channel name to invoke using the Postman REST client. You can now see the same patient result that was inserted from the ABC Lab organization.
Basically, in the last few years, we've been working with a lot of enterprise customers. We have seen that blockchain projects can often be slowed down by issues with complex infrastructure requirements, and we try to make sure the blockchain platform overcomes that. But still, lack of skilled chain code developers can be a hindrance to customers. So Blockchain App Builder provides two ways to help, right? First, it improves developer productivity by providing a local environment where you can do your local testing and simplifies a lot of the development steps and flows, makes them much more efficient. And the second means is by enabling low-code approach, right? So if you have a simple application like the ones that Bala showed, where you want to simply store for mutability the test results, for example, or some kind of documentation or other things, you can generate that kind of application without writing a single line of code. So we try to make enterprise blockchain easy, as I mentioned at the beginning, easy and quick. And our blockchain platforms and managed blockchain as a service infrastructure provides its capability with built-in API gateway, built-in identity management, and all of the tooling around monitoring, management, etc., that is available in our operations console. And now we've made it even easier for people to develop the chain code, and this rapid capability to generate chain code, test, and deploy it in blockchain application builder is going to continue to help enterprises make it easier to start getting involved with blockchain applications and use the power of blockchain to solve many different use case challenges that they have. If you want to get more information, you can find it on this links. Oracle.com/blockchain is our general landing page. There's also a developer site, a microsite. For blockchain application builder specifically, there are some articles started posted on our blockchain blog. You're welcome to come there. There is a video on YouTube where we go through much more detail and documentation link here for the application builder. Now, if you wanted to actually get your hands on it and play with it, there are a couple of ways you can do it. You can go to our OBP cloud page and register for a trial or register for an instance. And once you have the OBP cloud instance up and running and provisioned, in the console, you can go to the developer tools tab, and there's a download page where you can download the blockchain app builder. So it will download onto your local machine. It's available for Linux and Macs now, and soon will be available for Windows as well. If you're downloading the command line package, you don't need anything else. It's ready to go. If you're downloading the Visual Code extension, you of course need to go and separately install the Visual Code from Microsoft. But all of that is under developer tools in the console once you have provisioned an instance actually through the OVP Cloud. If you want to deploy on the OVP Enterprise, you can also download that. That's available as a an application, basically a virtualization, and it has a free developer license for 30 days as well. So thank you for joining us today, and happy to take any additional questions that you might have at this point.